Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we did correlation, Carl Pearson's correlation coefficient, and we did some of the questions which were asked in the PYQs, and it is one of the most important topics for your statistics paper 1. And today we'll be moving forward with regression, coefficient of regression. And before that, I would like you all to know, those who are preparing for 2027 ISS examination, we have launched a batch, Lakshya 2027. You can enroll in that, and you can apply for it. And those who will be selected will be given coaching by us and our team. And for more queries, you can ask anything on our WhatsApp channel, or you can call us anytime. So, coming back to the topic, we will today discuss regression coefficients. Regression coefficient is again linear and non-linear. There are two kinds of linear. When there is a scatter diagram between two variables or random variables x and y, then it is a non-linear regression. And when there is a direct relationship or a straight line, then we can say there is a linear relationship, linear regression between both the variables. So if I have to calculate linear, then first of all we need to know what are linear equation. There are two kinds of linear equation. First is equation y is linear on x, and the second is x is linear on y. So these two equations can be written as y is equals to a plus bx, and a and b are some arbitrary constants. Here y, here it can be written as x equals to c plus dy. These are the two linear regression line equations, and first of all we have to convert them into these forms so as to find our linear regression coefficient. So how do we define regression coefficient? First of all, we'll divide it on when y on x, y is regressed on x, and when x is regressed on y. So this is represented by byx, and this is represented by bxy. So the formula here is covariance between x and y upon variance of x. Here it will be covariance between x and y upon variance of y. We have another formula as well. It will be r xy sigma y upon sigma x, where sigma y and sigma x are the standard deviations and rxy is the correlation coefficient. So this is the relation between correlation coefficient and our regression coefficient. Here also we can write it as byx is equals to rxy sigma x upon sigma y. These are some of the important things, the important derived final formulas that you need to learn by heart. Now there are some properties of this, properties of regression coefficient. The first one is that regression, although our correlation coefficient were equal, but our regression coefficients are not equal. This should be kept in mind. Then the second one is this regression correlation is always greater than equal to 1. Sorry, is always less than equal to 1. And the third one is that if any bxy into byx, these two relation coefficient has the relation as rxy whole square. This is equal to this. This is a very important relation, and this have been asked multiple number of times in the questions, not directly but indirectly. So one more thing, if bxy is greater than 1, then byx should be less than 1, or either of the one. If bxy is less than 1, then byx should be greater than 1. This is our fourth and the last property. So these were the properties of our regression correlation regression coefficient. Now let us move to some of the PYQs. So this is your PYQ of 2019. Here they have given us two regression equations. First is x is equals to 4y plus 5, and the second is y is equals to kx plus 4. So they have already given us in that format which we have done, x equals to and y equals to, so we don't need to convert. And then what is the which of the following is true? Now we have to find what is the value of k. So here it will be bxy, which is x is the lines of regression of x on y, and the coefficient of y here is 4. So our bxy will be 4. And if we see here byx, which is the regression of line of y on x, the coefficient is k. Now we know that these are y, rxy square is equals to bxy into byx. So bxy into byx can be written as 4 into k and rxy square. And we also know that rxy square, rxy lies between -1 and 1. And if we square this term, it will be 0 to 1, because rxy square will always be positive, not negative. Okay, and 0 will not here, it will be 1 only. So instead of this, we can write it as less than equal to 1. So here if we put the value of 4k, 4k is less than equal to 1, and k is less than equal to 1 by 4. And if we take the value instead of minus, if we are taking here -1 and we take the positive ones, so we will convert this limit from 0 to 1. So from here we can also say that it lies between 0 to 1, and this k also lies between 0 to 1 by 4. Dividing by 4, 0 will remain 4. So our option number D is the correct answer. Now moving forward to another question. Here they have given us three statements. First of all, the percentage of variation in the dependent variable explained by the independent variable is 49. So they have given us coefficient of correlation as 2.7. So rxy has been given to us as 0.7. So the explanation of the variable is always rxy square, which is 0.49, which can also be written as 49%. So hence we can say the percentage of variation is 49. This is the true statement. Okay. First, then the second is both the regression coefficient have positive sign. Now, if we have been given a regression coefficient rxy as a positive number, then we conclude that bxy and byx are also positive. And if rxy is negative, then we conclude that bxy and byx are also negative, and vice versa. If bxy and byx are positive, then rxy will be positive. In bxy and byx are negative, if either one of them are negative or both of them are negative, then rxy will be negative. So here we can see that rxy, which is the coefficient of correlation, is positive. Hence the regression coefficient have positive sign. This is also true. And here they have given that they have negative sign, so this is false. So which all statements are true? Only 1 and 2. Option number B. This is how we solve them. For this you need to know about our properties of this regression coefficient. Here this is another question from 2019 where they have given us two equations. Y is equals to ax plus b and x equals to cx plus d. These are two regression equations. So first of all, let us calculate b yx, which is regression coefficient of y on x, which will be equal to a. The coefficient of x is a, and here it is bxy, which will be equal to c. The regression coefficient is on x is c. So we have calculated this, and they have given us that rxy is correlation coefficient. So if we say that rxy is coefficient correlation, the square of rxy is byx into bxy, and from here we can say that it is nothing but a into c. And if we remove the square from here, it will be under root of ac, which we can write it like this. Now since these two are positive, so this will also be positive. We are not writing plus minus sign, we'll just put it positive. So first thing we have calculated. Then the second thing is the standard deviation xs upon sy. Now we have calculated one more term, that byx is nothing but rxy into sy upon sx, right? So byx we have been given as a, rxy is under root of ac into sy upon sx. Now if we take this whole term on the left hand side, it will become sx upon sy, which will be under root of ac upon a. Under root of ac upon a will give us root c upon a. So our standard deviation sx upon xy is under root c upon a. And what they have asked us, the values of these two. So rxy is under root ac, which is given in D and A, and sx upon xy is root c upon a, which is given in option number A, and hence this is the correct option for this question. Now moving forward to our last topic or last question for today. This is our PYQ of 2021, and this holds very important concepts of joint density function, how we will be using regression. So they have given us the joint density function of x and y. So this is f x y is equals to 8xy for all x is less than y is less than 1. Now they have given us to find the expectation of y given s. Now expectation of y given x, if we have to calculate, then this will be equal to integration of y into f y given x dy with the limits of y, right? So first of all we have to calculate here uh, PDF of y given x. Now PDF of y given x can be written as joint PDF of x and y upon the PDF of x. So for PDF of x, we have to calculate fxy is equals to fxx is equals to the limits of y. From here, the limits of y are from x to 1. So x to 1, and the normal PDF, which is 8xy, joint PDF 8xy with dy. From here, we get our answer as 4x 1 minus x square. This is our fxy. Now fx. Now keeping it here, it will be 8xy upon 4x 1 minus x square. And cancelling the terms, we will be getting 2y upon 1 minus x square. So now calculating our expectation of y given x equals to x. It will be integration over y. So integration over y will be from x to 1 again, and the terms are 2y upon 1 minus x square into y dy. So instead of writing this like that, I am writing 2y square. And by opening the bracket, it will be 2 upon 1 minus x square integration x to 1 y square dy. Now integration of y square will be y cube by 3. So it will be y cube by 3 with the limits x and 1. The limits x and 1 will keep this as 1 minus x cube upon 3. So our answer will be 2 upon 3, 1 minus x cube upon 1 minus x square, which matches with our option number C. So this question included both the PDF distribution function terms and this also regression terms also. So this is the expectation of regression of y on x. I hope that this topic is clear and all the PYQs are clear. And if you're facing any doubt in any of the part or any topic, you can ask us in the comment section or on our WhatsApp channel. All the best. Thank you.